Preventing Nuclear Terror in Our Backyard. Presentation brought to you by Christopher Alonso Cornejo, Jayrudra, Sharma, Marco Cavaliere, and Ryan Zheng. The audio presentation will also be presented by the same four members in the order as their name appears on the presentation. Challenge statement. The problem that we intend to address is to control and track all nuclear materials so it's easier for the government to know where and who's utilizing the material to prevent nuclear terror. By addressing our problem to the United States government, we can hopefully have a more sophisticated system implemented to prevent major population centers around the United States from being attacked through the use of machinery that will track nuclear materials. Relation to the grand challenges of engineering. Our solution relates to the grand challenge of preventing nuclear terror by directly continuing its mission of making it harder for nuclear materials to get into the hands of terrorists. By implementing systems to detect these materials in cities and vital infrastructure, we can ensure that if the current safeguards implemented throughout the United States fail and material gets out of these areas, it will not be long until they are tracked down before they can harm citizens of the United States. Our target audience and affected populations. Our target audience for both funding and initial responsibility of implementing our plan is the federal government and departments within it. Particularly, we plan to pitch to the United States Nuclear Regulatory Commission, the EPA, and the U.S. Customs and Border Protection Agency. When we receive approval for funding, we would like to see major cities experience a gradual improvement in security against nuclear terror. Major cities and the residents within the affected areas of the rollout will receive these upgrades.
Our solution primarily focuses on using pre-existing systems in place that have been put into protecting and securing materials in ports of entry, airports, and nuclear power plants, implementing them in major cities, important interstates, highways, and several other important civil centers as it is the most logical next step. During our first phase, we will secure government backing and funding. For our second phase, we aim to secure local government interest in being adopters of the program. During our third phase, we aim to collect data from early adopting cities, modify aspects, and implementation. During our fourth and last phase, we aim to roll out into all major American cities, securing every major population center from nuclear terrorism.
We have not found any similar solutions to our proposed solution. However, we have found similar theories and ideas that have not yet been put into practice. So there do exist some procedures and technology for detecting radioactive materials, such as TSA checkpoints at airports, but they're not implemented on a large scale across the country as we would like. We would like to install similar technologies along US highways and interstates at toll booths, for example, to detect for radioactive materials. Um, and then when talking about the feasibility of the study, we need to talk about the Geiger counter and the mass spectrometer. So the Geiger counter basically detects the gamma rays that radioactive materials emit, and these devices can cost anywhere between $100 to $1,000. And the mass spectrometer allows us to actually detect which radioactive isotopes are present in the material. And installing this technology can cost anywhere from $60,000 to $200,000. So the maximum cost of each installation unit at each location would be around $201,000. And we do not believe that the government would think twice before investing this sum of money because it would massively increase public safety and the overall security of our country.
Next, we have our design shortcomings. Not every US highway has toll booth where cars are required to stop. Before continuing on, this creates a gap in the coverage of these detectors. To combat this, the detectors can be installed at traffic lights off of highway exits leading to big cities. When the light is red, the cars will be stopped for long enough to detect nuclear materials. Other shortcomings include the massive sizes of current devices, prices of said devices, or even retaliation from the local communities as they may not like the sight of the new machinery. The next steps of our project is to design a prototype of our solution and perform multiple testing operations on our prototype. Present our solution to possible sponsors to allow us to design our final product with sufficient money and support. Here's a QR code linked to our sources. Thank you.